Hello and welcome to another quick maths tutorial, and in today's video I'll be going over how to do synthetic division, which is a algebraic division method often used instead of polynomial long division, where you can divide one polynomial with a higher degree than another. So we're going over some basic terminology, and here I have a equals bq plus r. This is the basis of the remainder theorem, where one polynomial a is equal to another b times q, which we're going to call the quotient. I'm going to explain what these all mean, plus some remainder r. So what I'm basically saying, if the remainder r is 0, then b and q is the factors of a, right? And b is what we call the divisor. That's what we're dividing by. And a is what's called the dividend. That is what is being divided. And the leftover amount, which is what we'll be working out, is q, the quotient. But if b doesn't divide a perfectly, there's a remainder, that's where r steps in. And the last few, I don't actually have these up, but I'd like you to know is degree of a polynomial is the highest power it has. And the leading coefficient is the multiple, so the number in front of the degree of the polynomial. So if it's the highest power is x to the 4, whatever number is in front of x to the 4 in the polynomial is the leading coefficient. In our first example, we're going to be dividing x cubed minus x squared minus 12x plus 18 by x minus 3. So first we flip the sign of the x minus 3, so the 3, and we ignore the first term. And let's write out all the coefficients of the dividend up top. So with the flip sign 3, what we're going to do is first bring down the first coefficient, which is 1, and then we're going to multiply that by 3 here, and put that underneath the second coefficient of the dividend. And we're going to add these two numbers in the column up and place that above under the bar. And now we multiply this by our 3 to get 6. Again, we add these two up, and what we get there is we get minus 6. And we repeat the process. 3 times minus 6 minus 18, and their sum is 0. And everything under the bar is going to be our coefficients of our quotient in decreasing powers. Now we have a degree of 3 divided by a degree of 1, which means our quotient's going to have a degree of 2. And what's left over is the remainder. That's how we decide what the remainder is. So what we have is we have 1 lot of x squared plus 2 lots of x minus 6. That's our constant, with no remainder left over. X minus 3 is a factor. So in the second example, what we're going to do is we're going to ignore the first term, and what we're going to do is we're going to write the coefficients with signs flipped, so plus x becomes minus 1, and minus 3 becomes 3, of the other two terms in that order. And we're going to write out the coefficients of the dividend, so that being 1, minus 12, and 0, because we've missed x, 42. We have to have the placeholder 0 for that. And we drop down the first coefficient, and we multiply that by the first part of the divisor, minus 1. We write that in the next column, but we also multiply our 1 by the next part of the divisor, the 3, which gives us a 3. And we put that in the column. We have like a diagonal line going from 1 here. And we add up in the first column what we can to get minus 13. And now we do minus 13 by our divisor's terms. So that gives us plus 13 and minus 39. Now we can't go any more now because we've gone under all of our coefficients of the dividend. Now we add these two up. Now there's going to be a mistake here. That's meant to be 16. Sorry, it's I'm not thinking straight. But apart from that, the rest of it should be fine. And what we get here is we get minus 81. Now we're dividing a degree 3 polynomial by degree 2, which means we're going to have our quotient as degree 1, which means just x is the highest power. So we have 1 lot of x here, that's what the 1 is for, and minus 13 is our constant, and the rest is a remainder with degree 1 because we have two terms. So the remainder is a bit more complex than just a number, which is why I chose this example. So minus 13. Now the remainder should be 16, as I said before. Just ignore that. I'm sure you should get that yourself. And we write that over the divisor because that's technically the actual remainder. in that case. Now it's one more example to look at. This is when we don't have a mnemonic. So this a mnemonic, sorry, which is where the first term of the divisor has a coefficient that's not 1. I'll talk about how to deal with that because our first term of the divisor is 3. So we've written out our coefficients of the dividend. Now we write the flip signs of the not the first terms of the divisor. So minus 2 becomes 2, minus 1 becomes 1. But the 3 we write down here because we're going to be affecting our numbers with this 3. So we bring down the 6 as normal, and we divide it by this 3 because it's not a mnemonic. And we have a 2 there. And then we use the 2 with the 2 and the 1 up there to give our diagonal like we've been doing before. Not the 6, the 2. And we add up the second column, which gives us 3. And then which gives us 9, and which we divide by 3 again. And then we use the 3 and multiply those 2. And now we can't fill up any more columns, and we just add up the numbers. But we don't divide this because we're finished by the 3. Those stay there. And interesting enough, those are the remainders because we're actually finished. That was quite fast for doing this now. And we have our numbers here. So we just have to add them up now, and we have all our answers. We have x to the 1 because we're dividing a degree 3 by a degree 2, so it's just a degree 1 quotient. So you have 2 lots of x, and our constant term is 3. Look, we've got all our coefficients. And the remainder is 8 lots of x on top minus 4, and that's over our divisor. So this is the most extreme example where you've got a coefficient of the first term of the divisor. That's as hard as you can get, really. So I hope you enjoyed this tutorial, and thanks for watching.